Hello and welcome guys. Now in this video we will be learning about different type of regression error. Now you can see that most probably we have 5 different type of error in regression, but it depends what you use based on some problem statement. So it's completely based on that, and we'll come to the categorical errors later on. But since we are learning logistic regression, so let's learn about all different type of error that we will be using in our day-to-day life. Okay, so in regression analysis there are different type of error that can occur while building and testing the model. So here are some common type of error. So first is residual error. That is, residual error is basically difference between the actual value and the predicted value. So mathematically this is how it looks like: actual value minus predicted value. And this error is also known as vertical deviation of data point from regression line. Okay, after that it mean squared error. Okay, so mean squared error is the average of sum of squared error between the actual and predicted value. So mathematically it is expressed as 1 by n into sigma of actual value minus predicted value whole square, where n is the total number of data point and the error represents the overall performance of the model. So most of the places you will see that we will be using mean squared error, and after that we have mean absolute error. Commonly it is also known as MAE, and so this error is the average of absolute difference between actual and predicted value. So mathematically it is expressed as 1 by n into sigma of mod actual value minus predicted value. So this error represents the average magnitude of error in the prediction. Okay, so this most of the error come never come negative, but basic difference will be mean square error penalize large error more heavily due to the squaring, and it is sensitive to outlier, so it can result in negative value sometime if the model prediction are significantly worse than the mean of target variable. On the other hand, mean absolute error is robust to outlier, and it does not produce negative value. It is almost interpretable metric since it based on absolute error. So the choice between mean squared error and mean absolute error depend on specific goal of your regression analysis. So we basically use MSE when you want to penalize large error more severely, and when you are less concerned with the interpretation of error metric. And this mean squared error is widely used in case where we have small error and it matter less, and you want to optimize the model for precision. And just remember, we can use mean absolute error when you want more interpretable error metric, and when you want to be very less sensitive to outlier. So MA is like often used in case where all errors should be treated equally and precision is not as critical. So hope this is clear when to use MAE, when to use MSE. Other error is root mean squared error, that is also called as RMSE. Okay, so root mean squared error is square root of average of sum of a squared error between the actual and predicted value. So mathematically it is expressed as a square root of 1 by n into sigma of actual value minus predicted value whole square. And this error completely looks similar to mean squared error, but it is in the same unit as dependent variable, making it easier to interpret the values. Then we have R squared, that we also call R2. So it is a proportion of variance in dependent variable that is explained by the independent variable in the model. Mathematically it is expressed as SSRES, so which basically means sum of squared residual, and SSTOT, which is total sum of square. So basically SSRES is the sum of squared residual, and SS total is the total sum of squares. So basically this R2 ranges from 0 to 1, with higher value indicate better model performance, lower value means it didn't able to explain the good model. Okay, so that is what it is. Next we have MPE, which is mean percentage error. So basically mean percentage error is the average of percentage difference between actual and predicted value. So mathematically it is expressed as 1 by n into sigma actual value minus predicted value by actual value into 100. So this error represents the average percentage deviation of prediction from the actual value, and it is important to evaluate and consider those error while building and testing the regression model. So by minimizing this error we can improve the accuracy and reliability of the model. So lastly, the question is when to use which one. Okay, so just remember guys, so the choice of error metric depend upon the problem and goal of the model. So here are some guide that I will tell you which is appropriate error metric for different scenarios. So so for mean squared error, this is appropriate for models where objective is to minimize the average square distance between predicted and actual values. And this MSE is useful when error is symmetrically distributed, and the magnitude of overestimation and underestimation error are same. Use mean absolute error, since it is also widely used and appropriate when the model need to be minimized. And the error, like average absolute distance between predicted and actual value, need to be reduced. So MA is useful when the error is not symmetrically distributed and the magnitude of overestimation and underestimation error are not same. So we use root mean squared error when we want to penalize large error more than a small error. Okay, so root mean squared error is useful when the model need to be minimize the average square distance between the predicted and actual values, but with more emphasis on large error. Okay, so when there is large error, make sure you use RMSE. Then we have R2 or R squared. So it is like a statistical measure that present the proportion of variation in dependent variable that is predictable from independent variable. Okay, so R2 is useful when the objective is to understand the proportion of variation in the dependent variable explained by the independent variable, which is what we were looking in the past few videos. Now the choice of error metrics also depend upon the nature of data. For example, in classification problem, error metrics such as accuracy, precision, recall, and F1 score are used. In time series forecasting, error metrics such as mean absolute scaled error and systematic mean absolute percentage error are used. It is important for everybody to understand the problem and choose the appropriate error metric accordingly. Now you guys know which error metric to use. So hope this is clear that whenever we start a problem, we need to understand also which error metric making sense, and basically which is critical to choose, because sometimes choosing correctly predicted data points are more important than wrongly predicted one. Sometimes wrongly predicted data point are more important than the uh, not correctly predicted one. So we just need to understand which one is very important for us, for the business and for the client. So this is done by many you know brainstorming call, and I think this will be more clear later on when we will be solving multiple problem at hand. So yeah, that's all the types of error we have in regression. Now in the next video we will be learning about goodness of fit.